3, 6, day 1, consecutive integers. When we are dealing with consecutive integer problems, just like with any other word problem, the first thing we have to do is define our variables, or in this case, what I call variable terms, because there's going to be multiple terms, but we want to make sure we're using the same variable in each of them so that we're able to solve them once we set up the equation. So one of the things that we'll be asked for is to find consecutive integers. Consecutive means in order, one right after the other. So if we are looking at finding consecutive integers and we want to use variable terms to represent each of those integers, in this case, we're going to have 3 of these. It could be 2 consecutive integers. It could be any number of consecutive integers that you're asked to find. The number of variable terms that you define will just have to match how many of them you're told you need. So when you define your variable terms, the first term that you're going to use or define would just be a regular variable. I use the variable n a lot when I do these types of problems. You could use x, you could use any variable that you wish to use. But now, like I mentioned before, you don't want to use a different variable for the next consecutive integer, because if you do, you won't be able to solve your equation. So you want to use the same variable, in my case n, but in order to represent the next consecutive integer, we'd have to add 1 onto the original variable that we used for the first integer. And then if I want a third one, I'd have to add another 1 onto the one that I've already added for my second integer. And if I add 1 twice, that's really like I'm just adding 2. So the 3 variable terms that we would need to use if we are dealing with 3 consecutive integers would be n, n plus 1, and n plus 2. An example of 3 consecutive integers are the numbers 3, 4, and 5. If you think about 3 being that n, that original variable, if I add 1 onto that original number, I get 4, which is the next consecutive integer. And then if I add 2 onto that original number 3, that's how we would arrive at the number 5. If we are asked for consecutive even integers, so now we're not looking at 3, 4, 5, for example, maybe we're looking at 2, 4, and 6. We want to come up with 3 variable terms since we were asked for 3 consecutive even integers. We'll start the same as we did with regular consecutive integers, so we're just going to use n or x or whatever you want to use. But now to go from the first even integer to the second one, we're not just adding 1 anymore, we're adding 2 this time. So our second variable term is n plus 2. To go from 4 to 6, in our example, we're adding another 2 onto the 2 that we've already added, for really a total of 4 being added onto the original. So again, with consecutive even integers, if there were 3 of them, you'd have n, n plus 2, and n plus 4. With consecutive odd integers, it's actually the same thing as consecutive even integers. So I've got an example of 5, 7, and 9 for my 3 consecutive odd integers. Again, I represent the first of those odd integers with a regular variable. The second one I would find by taking the original odd integer and adding 2 onto it. And then the third one I would add 2 again. So again, this is plus 4 because I added 2 originally. I added 2 more. That means I'm adding a total of 4 for that third consecutive odd integer. So some examples of these types of problems. We're told here to find 2 consecutive integers whose sum is 113. So a couple things we have to be very careful with while we're reading these problems. How many consecutive integers we're told to use. So that tells us how many variable terms we have to define. So in this case, if this says just 2 of them, and it says consecutive integers, that means I can count by 1. My 2 variable terms would just be n and n plus 1. So I like to list those as the 2 variable terms. I'd have my first consecutive integer and then my second. From there, we're told that the sum of those integers, the sum means to add, is 113. Is means we put an equal sign. So we have to write an equation using our variable terms and the operation that's told to us in the word problem equal to our total. So n plus 1 equals 113 is our equation. From there, we're just solving like we've already worked on. So first step would be to combine like terms, making it 2n plus 1 equals 113. Now I'm going to subtract the 1 from both sides to get 2n equals 112. Lastly, I divide by 2, and we have n equals 56. So that 56 is actually the first consecutive integer that we were asked to find. So that's our n. So I generally will go back and write them over here closer to where I defined my variable terms. You could write them down at the bottom under the problem. It doesn't really make any difference. Now to find my next one, okay, I take the 56 and I add 1 onto it like I've defined with my variables so that my second consecutive integer is 57. So the answers for this first problem are the consecutive integers 56 and 57. If we go over to the second one, finding 3 consecutive integers, now before we even go any further, if we have to find 3 consecutive integers, again, it does not say even, it does not say odd, so we have to realize that we would just be adding 1 each time to get to the next consecutive integer. So our 3 variable terms would be n, n plus 1, and n plus 2. From here, we're again told that the sum of those consecutive integers, so we're going to take all 3 of these variable terms, we're going to add all of them together and set them equal to negative 66. So the equation would start off like this. Now solving, we again combine like terms. So all 3 n's add up to 3n. The 1 and the 2 add up to 3. Notice I'm just adding them together the way that they are. I'm not taking them to the other side or anything. I need to keep those things on the same side and just combine like terms. Now we will subtract the 3 because it's being added. We have to use the inverse operation, which is subtraction. We get 3n equals negative 69. And then again, 3n is showing multiplication, so we divide to find that n equals negative 23. So if n equals negative 23, that's one of our parts of our answer. If we add 1 onto that to get the second part, that would give us negative 22. And then lastly, if we take n, which is negative 23, and add 2 onto it, we would end up with negative 21 as our third consecutive integer. Number 3 tells us to find 3 consecutive even integers. So we have to be careful with our reading again now. We're needing even integers, 3 of them. So when we define our variable terms, again, the first one is n, but now because it says even integers, we have to count by 2 or add 2 each time. So we have n, n plus 2, and n plus 4 for these variable terms. We're again just given that the sum of those 3 consecutive even integers is 240. So we take those 3 variable terms, we add them together and set them equal to 240. Again, combining like terms, subtracting, and lastly dividing, we find that the first of those consecutive even integers is 78. So we know the first of 3 parts of our answer. If I take that first even integer and I add 2 onto it, we would find 80. And then lastly, taking that first even integer of 78 and adding 4, we would end up with 82. So 78, 80, and 82 would be our 3 consecutive even integers. Finally, here we have to find 3 consecutive odd integers. So again, remember that even and odd integers are found the same way when it comes to defining the variable terms. We still start with a regular variable, And again, we are adding 2 each time to find each of those consecutive odd integers. From here, we would write our equation. Again, we're told the sum, so that means we're adding all of those variable terms together, setting it equal to the total we're given, which is negative 129. Combining our like terms, we get 3n plus 6 equals negative 129. Subtracting 6, now this is where we have to be careful. A lot of people will subtract, and they'll actually make this negative 129 negative 123, which is not what it would be if you subtracted 6. It becomes negative 135. So again, using a calculator, just check yourself. May not be the worst of ideas. And then lastly, when we divide by 3, we find that n is negative 45. When these are negative values, just like it was in number 2, have to take a little bit extra caution when you're finding your next couple of consecutive odd integers. I've seen multiple times where students will take negative 45 and then they'll say their next consecutive odd integer is negative 47, which that is true, but it's not going in the right direction. So if we're adding 2, it actually is negative 43 for our second consecutive odd integer, and then the third one would be negative 41. Now we have a little additional question here. What if the question asked you for 4 consecutive integers? You've seen an example where there's 2 consecutive integers. You've seen 3 consecutive, 3 consecutive even, 3 consecutive odd. What if it asked you for 4? Is that even possible? Well, yeah, it is. We could use any number of consecutive integers for these problems. I could ask you for 5 of them. I could ask you for whatever value of them I would like to. And how would you show those? What would those 4 integers be? How would they be defined for the variable terms? Well, you'd start out the same way. You would just make sure you have 4 of them. So the first one is going to be n, or x, or again, whatever variable you decide you want to use. The second one would just be n plus 1, because it doesn't say odd or even. If it's just regular consecutive integers, you're just adding 1 each time. The third one would be n plus 2. And then finally, your fourth one, you would have n plus 3. So there's 4 consecutive integers represented here with these variable terms. And again, we could do this with any number of consecutive integers that we decided. So now I'd like you to try, find 3 consecutive even integers, whose sum is negative 36. Hopefully, your work looks like this. Because we have even integers, consecutive even integers that we're asked for, we have to have n plus 2, and n plus 4 as our variable terms. And again, we're just told the sum is negative 36. So we take those 3 variable terms, add them together, set them equal to that total of negative 36. And then we just go through our solving. We combine like terms, subtract the 6 from both sides, divide each side by 3 to get negative 14. Using that now, and basically plugging it into those 3 variable terms, you would find that your 3 consecutive even integers are negative 14, negative 12, and negative 10. Next, we'll have you try the second one. Find 2 consecutive integers whose sum is 247. With this, because it does not say consecutive even or consecutive odd, your variable term should be n and n plus 1. Again, adding those together because we're given the sum and setting it equal to that total. Combining like terms, subtracting, dividing, you get 123. Finding your second consecutive integer by adding the 1, 123 and 124 would be your 2 answers. We can use this same idea of consecutive integers, but write questions that are a little bit more on the next level from these just kind of more simplistic problems. The length of the sides of a triangle are consecutive odd numbers. What is the length of the longest side if the perimeter is 45? Well, we have to think about this. A triangle, hopefully everybody is comfortable realizing that a triangle has 3 sides. And if you're talking about the perimeter of a triangle, unlike a square or a rectangle or a lot of other shapes, there is no specific formula for the perimeter of a triangle other than to simply add the 3 sides together. So again, this is another problem where you're going to take 3 consecutive odd numbers, 3 again because of the triangle, and you're just going to add them together. You have the sum, which is 45. So really, this problem is no different than any of the other problems that we've already done. The idea of there being 3 of them and the idea of having the sum is just presented in a little different way. So again, if we have 3 consecutive odd numbers that we're dealing with, when we define our variable terms, that should be n, n plus 2, and n plus 4. And again, knowing that the sum of those is 45, we would take and add those 3 variable terms together and set them equal to that total of 45. Combining like terms, subtracting, and then finally dividing, we would find that n is 13. So now it's your job to answer the question, what is the length of the longest side of the triangle? Well, if we take n as 13, that means the second side is 15 and the third side is 17. The length of the longest side is what you were asked for. So really the only answer is 17. Yes, you have to use everything else that you see to get there, but 17 is the final answer that you'd have to provide. All right, our last problem, again, takes what we've been working on and kind of raises it up to the next level here. So John has a board that's 5 feet long. He plans to use it to make 4 shelves whose lengths are to be a series of consecutive even numbers. How long should each shelf be in inches? So the first thing, all right, and it's bolded for you to help draw your attention to it, is that you're given 2 different units. You're given the unit of 5 feet in length. You want inches. So the first thing that you might need to do here is you might need to do a conversion. Pretty simple conversion. But if we think of this using the dimensional analysis or unit analysis process that we've covered, we would take the 5 feet and we'd write that as a rate or a fraction. And we'd want to multiply that by another rate that would allow us to convert from feet to inches. What rate would we put right here to correctly convert from feet to inches? We would need to use the rate of 12 inches per 1 foot. Again, this has to be written this way so that your feet labels would reduce each other out, one on top and one on bottom, or numerator and denominator. And then we would take 5 times 12, and that would give us 60 inches. So 5 feet really is 60 inches, and we're going to use that new number because of how we are asked for our final answer. So now back to the idea of this being a consecutive integers problem. We're told that there are 4 shelves that are going to be a part of this project, and they're consecutive even numbers with their lengths. So if there's 4 of them, this goes back to what we talked about on the front side. And now with even, we're adding 2 each time. We need 4 variable terms. The first one being n, then you'd add 2 for the second one, add 2 more to make a total of 4 that are being added on the third one, and then again add 2 more for a total of 6 being added to the 4th variable term. From there, if we have a total of 60 inches of length to use, we have to understand that you would be adding those variable terms together again to equal that total length. The length of each individual board added together should equal the entire length of the material used to create this project. So now simplify by combining like terms and solve for n. We end up with n equals 12. Again, combining like terms, subtract 12 from both sides, and divide by 4. That means our 4 lengths, numerical values would be 12, 14, 16, and 18. However, because of the context of the problem, and not just, or the fact that it has context, it's not just straightforward numbers, your answer would also have to include labels. So 12 inches, 14 inches, 16 inches, and 18 inches would be the 4 lengths of each shelf.